In this video, we're going to take a look at what are the specific choices for beta 1 hat and beta naught that kind of optimize, give us the best equation of the line. How do we find those choices? And then we'll roll through an example where we will do that. All right, so our best choices for beta 1 hat is given by this. So it's s with a subscript of x times y divided by s with a subscript of x times x. So that s with a subscript of x times y, there you're taking the actual x values minus the mean of all of the x values times an actual y value that is associated with that x value minus the mean of all the y values. You're taking those products, each of those pairwise products, then you're going to add all of those up. So that's why it's called xy. So we're taking the x values minus their mean times the y values minus their mean, and we're adding all of those up. So it's a sum. For the sxx, it is the same thing, same general idea. We're going to take the x values minus all of their means times the x values minus all of their means, and we're going to sum all of those up. So it's a sum of each of the individual x values minus their means times each of the individual x values minus their means. That's why we have a square here. Now, that's the formula, but in practice, we will add all of that up in a different fashion. It will be less costly for us to do it this way, simpler. And so for that first s sub xy, we take each of the x and y values, the actual observed x and y values, and just multiply them together. And then we take the sum of just the x values times the sum of just the y values, multiply those two things together, and divide it by n. Right? So that's how we would find this s sub xy. And s sub xx is very similar, only everywhere up here where we saw a y, we're just going to replace it with an x sub I. So this becomes x sub I squared, and this becomes the sum of x sub I times another sum of x sub I, which is why this is squared right here. So then we'll take this sum right here and divide it by this sum right here, and that will give us the beta 1 hat. The beta naught, we take the mean of all the y values minus whatever we found for our beta 1 up here times the mean of all the x values. All right, so let's go through an example. We want to use the method of least squares to find, to fit a straight line to the data points given below. So for our x values, we have -2, -1, 0, 1, and 2. For the y values, we have 0, 0, 1, 1, and 3. In this next column that I have, we are going to take the x value times its associated y value. So -2 times 0 is 0. -1 times 0 is 0. 0 times 1 is 0. 1 times 1 is 1, and 2 times 3 is 6. And then the final thing that we are going to do over here is we're going to take each of the individual x values and we're going to square them. So -2 squared is 4. -1 squared is 1, 0, 1, and 4. For each of those columns of values, we are going to get some sums. And so this column adds up to 10. This column adds up to 7. This adds up to 5. And our x values, that just adds up to 0. All right, so if we want to find beta 1 hat, so our choice for beta 1, we're going to take the sum of all of the x sub I, y sub i's, right? So that is the sum of the red column. So we'll have that 7. So the sum from that red column minus 1 over n. So 1 over n, that is the number of pairs that we have. So we have 1, 2, 3, 4, 5. Here n is equal to 5. So we'll be subtracting 1 over 5 times, here we're going to have the sum of the x sub i's, so that is column 1. When we added up our x values, we got 0 times the sum of our y values. When we added up our y values, we got 5. And so our beta 1 hat, that was simply 7. I say it was simply 7. Actually, I lied. I called that beta 1 hat. It's not beta 1 hat. Whew, that was close. It was not beta 1 hat. That is just part of it. That's the numerator of beta 1 hat. That is the s sub xy. S sub xx. That is going to be each of the x values squared, which was the x sub I, so that is the 10, that's the green, minus 1 over n, so 1/5, times the sum of the x values squared. And so now I can say beta 1 hat is equal to not 7, but instead 7 over 10, or 0.7. The value then of beta naught is going to be, so it's the mean of the y values. We already found the sum of the y values. The sum of the y values was 5, and there are 5 values in total, so it's going to be 5 over 5 is the mean. And then from that, we are going to subtract beta 1, so we're going to subtract the 0.7, times the mean of the x values. And the mean of our x values is 0. Well, it's 0 divided by 5. It's the sum of the x values divided by the number of x values that we have. And so we end up with beta naught is equal to 1. And so finally we can say our equation y hat, our residual equation, our regression equation is beta 1 beta naught, which is that 1, plus beta 1 times x, plus 0.7x. So our residual equation is beta naught. So that is the line that best fits this data. What do we mean by best fits that data? We mean that the distance from these 5 points to that line, the smallest distance it would take from those points to that line, those squared distances are the sum of those squared distances have been minimized by this line. This is the best line in that sense. If you drew any other line and took the distance from these points up here to any other line and you squared each of those individual distances and you added those up, it's going to be more than the distances here. And that is our regression equation. Thanks, guys.